Okay, we're in section 5.3, which is something you're going to have to study on your own. But we have some matrices, and we put them like this. So this is A11, A12, no, that's A21, 2, 1, 1, 2, A22. So this is first row, first column, second row, first column, first row, second column, second row, second column. Each of these guys are something. So I could have temperature could be in the first column, and I could have pressure in the second column, and I'm saving these numbers in some order. They mean something to me. I could have a number of daughters in the first column. I could have number of sons in the second column, and then each wife would be, the first column could be wife, and the first row could be wife, and the second row could be wife, and sons and daughters that way. I could do something like that. So each of these entries have some meaning. Now, I have a identity matrix, 1, 0, 0, 1. If I take A and multiply that by the identity matrix, I get the same thing back. I could, this identity matrix could be a 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. It could be a 3 by 3, or a 4 by 4, or an 8 by 8, or a 30 by 30. It doesn't matter. But if I multiply A times 1, I get the same thing back, whatever it is. So I have rows and I have columns, and I say, well, I could have a 2 by 2 matrix, 2 rows by 2 columns. I could have a 3 by 3 matrix, 3 rows, 3 columns. I could have a 2 by 1, 2 rows, 1 column. And if I'm going to multiply A times B, if I were going to do that, then I would look at the rows. So if this is M times N, and this is A by B, then if I'm going to multiply this together, then N has to equal A. So the number of columns in the first guy has to be the number of rows in the second guy, and my answer, C, is going to be an M by N matrix, M by B matrix. That by that. Okay, so if I have something 1, 2, 1, which is a 3 by 1, and I try to multiply that by 2, 1, 3, 4, 5, 7, which is a 2 by 3, I can't do it. Cannot do. I can't do it because 1 is not equal to 2. That's why I can't do it. I can multiply, I can have A 3 times A, in which case so if A was 1, 0, 2, 1, then 3 times A would be 3, 0, 6, 3. Okay, I can subtract, I can do all kinds of things. Okay, if I have 2x plus 3y is equal to 4, and x minus 5y is equal to 1. I have 2 equations to unknowns. I could put them in a matrices. 3, 2, 2, 3, 4, 1 minus 5, 1. Then I could do elementary row operations on the matrices until I have an identity matrix sitting right there, 1, 0, 0, 1. As soon as I do, then my answer to x and y is sitting over here, x and y. Okay, so I could solve have you solved simultaneous equations that way? So elementary row operations are, I can multiply one row by another row, I can subtract one row from one row, I can multiply by something, subtract, I can do stuff like that. Anyway, so I want a 1 sitting up there, so I'd multiply by 1/2, the top row and have 1, 3 over 2, 2, 1, minus 5, 1. And then I take the top one and subtract it from the bottom one. I get 1, 3 over 2, 2, 0. This is 10, 13, minus 13 halves. This is minus 1. Okay, and then I want a 1 sitting there, so I'd multiply by minus 2 over 13, and I'd get 1, 2, 3 over 2, 2, 0, 1, plus 2 over 13. And then I want a 0 there, so I'm going to multiply times minus 3 over 2, and then subtract. So I'd have 1, 0, 0, 1, 2 over 13, and this is going to be 3 minus I'm going to add. If I multiply by minus that, then I have to add. Alright, so I have minus 3 over 13, and I have 26 over 13, so that leaves me with 24 over 13. So x is going to be 24 over 13, and y is going to be 2 over 13. So that's just something I can do with a matrix, other than do a determinant thing. All right, so now if I have x prime is x plus y, and y prime is 3x plus 2y, I could write that as x prime is equal to a x, where x cap, the great big X prime, is x prime y prime, and where a is 1, 1, 3, 2, and x is x over y. So I'm replacing my simultaneous equations with matrix notation so that I don't have to write down as much. Okay? Now, certain laws apply. The associative law applies to matrices. The associative law and the, what is this law anyway? Distributive law applies to matrices. But AB is not going to be equal to BA. That's not going to be the case. And if AB is equal to 0, it could be 0, B doesn't have to be 0, A doesn't have to be 0, but it could still be 0. Okay, good enough? I guess I have to do multiplication. If I have A11, A12, A21, A22, and I'm going to multiply that times B11, B12, B21, B22. So if I'm going to do that, then it's this row times that column that goes in the top right corner. So this row, that column, A11, B11 plus A12, B21. This row, that column, A11, B12 plus A12, B22. This row, that column, A21, B11 plus A22, B21. This row, that column, A21, B12 plus A22, B22. Okay, so I got 4 entries, 1, 2, 3, 4, and that's the way I'm going to get them. Okay, good enough? If not, study the rest of the chapter on your own. Okay. So now what we're going to do is we're going to have a group of simultaneous equations. We're in section 5-4. And we're going to be in the form x prime is equal to ax. Okay, so I'm looking at equation 1 on page 366, and I'm writing that as x prime plus ax. That's what I'm doing. And then I'm asking myself, well, how am I going to solve that problem? Okay, so what I'm going to do is I'm going to use the theorem on page 836, the 367, and I'm going to look at a minus lambda I, the determinant of it. I'm going to set it equal to 0. And with that, I'm going to find lambdas. And these lambdas are my eigenvalues. Eigenvalues. If this is a 2 by 2, then I'm going to have 2 eigenvalues. If it's a 3 by 3, I'm going to have 3 eigenvalues. For 4 by 4, I'm going to have 4 eigenvalues. Okay? Then I'm going to take those eigenvalues one at a time and go a minus lambda I times v, set it equal to 0, and I'm going to find eigenvectors. Eigenvectors. So if I have 4 eigenvalues, I'm going to find 4 eigenvectors, each of them associated with a lambda. So I'd have a lambda 1, a eigenvalue. I'd find a v1, an eigenvalue vector associated with it. Okay, and then I would say my solution x is going to be c1 v1 e to the lambda 1 t plus c2 v2 e to the lambda 2 t plus blah 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 blah. But this value x is not just one thing. This is going to be multiple things. So this could be, I could look at this as x is equal to c1. Well, my eigenvector could be a, b, c. If I'm 3 by 3, e to the lambda 1t. C2, c, d, e, f, e to the lambda 2t, plus c3, f, g, h, whatever they are, e to the lambda 3t. And then I could go back and say, well, x1 is going to be c1a e to the lambda 1t plus c2d e to the lambda 2t plus c3g f e to the lambda 3t. And then I'd still have a value for x2, and I still have a value for x3. And then I'd have to go and take those values and put them back in my original equation and see if I had an answer. Okay, happy with that? Yeah, I think so. That sounds perfectly okay to me. Anything weird going on in this chapter? Nothing at all. Nothing's up my sleeve. So I only have to work problems 1 through 21, so I'm going to look at problem number 2. Okay, so I've got x1 prime, 2x1 plus 3x2, x2 prime, 2x1, x2. I find that this is in the form x prime is equal to ax, where my a is 2, 3, 2, 1. Okay, I'm going to find eigenvalues. So I'm going to go a minus lambda I take the determinant, set it equal to 0. Okay, so I got 2, 3, 2, 1 minus lambda 0, 0, lambda. Determinant is equal to 0. I'm never going to write it that way again, but I did it that time. I'm going to skip that step all the time and go 2 minus lambda 3, 2, 1 minus lambda. Find the determinant is equal to 0. Okay, so I've got this guy minus that guy. 2 minus lambda times 1 minus lambda minus 6 is 0. Okay, so I got 2 minus 3 lambda plus lambda squared minus 6 is 0. I got lambda squared minus 3 lambda minus 4 is 0. I can factor that. Lambda minus 4 lambda plus 1 is 0. I find that my lambdas are minus 1 and 4. And we always write them in alphabetical order, so the minus 1 would go first before the 4. And then I say, okay, now I got my eigenvalues. Now I have to find my eigenvectors. So I'm going to go case 1, lambda 1 equals minus 1. And then I'm going to go A minus lambda 1I times some V1 has to be 0. Now, I'm going to do this by inspection. Every problem in the book and every problem on the test you're going to have coming up, you can do by inspection. Now, you can make it harder on yourself, or you can just admit that your mind can see the answer. Okay, so now we have to figure out what I is. A is 2, 3, 2, 1. So this is 2, 3, 2, 1 minus lambda 1I. Okay, so lambda 1 is minus. Minus and minus is 1. So it'd be 1, 0, 0, 1 times V1 is equal to 0. Okay, so I got 3, 3, 2, 2 times V1 is equal to 0. Okay, now you're going to tell me what V1 is. Minus 1, 1. Minus 3 plus 3 is 0. Minus 2 plus 2 is 0. Minus 1, 1. So now I have the first eigenvalue and the first eigenvector. Okay, now I'm taking the second case 2. Lambda 2 is equal to, and I forgot what it's equal to already, 4. Okay, so lambda 2 is equal to 4. So I'm going to take 2, 3, 2, 1 minus 4, 0, 0, 4. Multiply it by V2, and I'm going to get 0. All right, so I've got minus 2, 3, 2, minus 3. And times V2, and I'm supposed to get 0. Okay, so I'm going to write down that V2 is 3, 2. Okay, am I done?
How do you get the V's?
By inspection. I look at it. What do I need to make 0? So this 0 isn't really 0. This is really 0, 0, right? So what does V have to be? What do I have to multiply times this times that to get a 0 over there when I add them together? Minus 6 plus 6 is 0. Plus 6 minus 6 is 0. By inspection, I got the right answer. Now, there's a constant of integration sitting in front of these eigenvectors, right? Which means there's an infinite number of them. So 3, 2 is just as good as minus 3 minus 2. is just as good as minus, just as good as 1 2/3. Right? So what's the difference between 3 and 2 and 1 2/3? I mean, they both work, right? Normally what we do is we make them whole numbers, make them as easy as we can. But there's an infinite number of solutions to my problem, is what I'm telling you.
So could you go 6-4?
Huh?
Could you go 6-4?
Yeah, 6-4 works, yeah. And 30-20 works. And 300-200 works. All those guys work. Because there's a constant of integration sitting in front of them anyway. We normally go with the simplest looking one. Okay, I don't have a final answer yet. So what's my final answer? Final answer, x of t equals c1 v1 e to the lambda 1 t plus c2 v2 e to the lambda 2t. Okay, we rewrite it. X of t is equal to c1, what was v1? Minus 1, 1. Now, the eigenvectors have to be linearly independent. Is minus 1, 1 linearly independent from 2, 3, 2? So is the vector minus 1, 1 linearly independent from the vector 3, 2? Is there any constant I can multiply this guy by to get that guy? No. Then they're linearly independent. Okay. Now what was lambda 1? Minus, so this would be e to the minus t plus c2, 3, 2, e to the 4t. Okay, that means that x of 1 is c1 minus c1 e to the minus t plus 3 c2 e to the 4t. That means that x2 is c1 e to the minus t plus 2 c2 e to the 4t. Okay, so this is perfectly okay to write it that way. What I'm doing is I'm checking my work now because this is number 2. And then I'm going to write down x1 prime c1 e to the minus t plus 12 c2 e to the 4t. x2 prime minus c1 e to the minus t plus 8 c2 e to the 4t. Okay, now my problem says that x1 prime is supposed to equal 2x1 plus 3x2. Okay, so 2x1 minus 2c1 e to the minus t plus 6 c2 e to the 4t plus 3x2 plus 3c1 e to the minus t, 3 plus 6 c2 e to the 4t. There's going to be c1 e to the minus t plus 12 c2 e to the 4t. Does that work? Check. Now that's exactly how I would check my work. Now I'm going to check the other one. X prime 2 is supposed to be 2x1 plus x2. Okay, so 2x1, which I can't see, is minus 2c1 e to the minus t plus 6 c2 e to the 4t plus x2 c1 e to the minus t plus 2 c2 e to the 4t, which is going to equal minus c1 e to the minus t plus 8 C2 e to the 4t, and I don't even have to look because I remember that that one's right there. Now that's the complete problem. I found the eigenvalues, I found the eigenvectors, I expressed my answer properly, and then I checked my work. Okay. And on the next test, that's exactly what you'll have to do. Those of you with an A average will get to do it with a 6 by 6 matrix, and those without an A average will get to do it with a 3 by 3. Oh, you think so? All right, whatever. Yeah, whatever. Does it matter? No, whatever problem's given is good enough, right? Any problem in a storm. All right, number 2. Number 4. x1 prime. 4x1 plus x2, x2 prime. 6x1 minus x2. I find that my A is 4, 1, 6, minus 1. I have to solve for my eigenvalues. So I'm going to have A minus lambda I, and I'm going to take the determinant of that. So I have 4 minus lambda, 1, 6, minus 1 minus lambda. I'm taking the determinant. I get 4 minus lambda minus 1 minus lambda minus 6. And I'm going to set that equal to 0 and solve for lambda. Okay, so I've got minus 4 minus 4 minus 3 lambda plus lambda squared minus 6 is 0. So we've got lambda squared minus 3 lambda minus 10 is 0. We're just trying to redo your 9th grade math again, right? So this factor is lambda minus 5, lambda plus 2 is 0. So my lambdas are in alphabetical order minus 2 and 5. Okay. Now we got to find lambda. We have to find the eigenvectors. So case 1, lambda 1 is minus 2. We want A minus lambda 1I times V1 to be 0. And we remember what A is. A is 4, 1, 6, minus 1. 4, 1, 6, minus 1 is what A is. Okay, so I got minus 2, so that'd be a plus 2. So I got 6, 1, 6, 1. Do I? Is that what I got? Minus 2 plus 2, 6, 1, 6. Yeah, that's what I got. V1 is equal to 0. Can somebody tell me what V1 is? Gonna have to be quicker than that. Minus 1, 6. Okay, by inspection, is that hard? By inspection, this works. Now, Annette does not like me telling you to do it by inspection because you're going to go running to her crying because you can't solve the problem, and she doesn't want to do it by inspection. She wants to do it a different way. All these problems are easy, and you should always be doing them by inspection. Lambda 2 is fine. How would you do it if it wasn't by inspection? You have two equations, two unknowns, right? 6x plus y is equal to 0. 6x plus y is equal to 0. Solve for x and y. There's an infinite number of solutions, right? That's why you're doing it by inspection, because it's so easy. Okay, so lambda 2 is 5. All right, so I've got that being the case. I've got minus 1, 1, 6, minus 6. V2 is equal to 0. All right, what's V2? V2 is equal to 1, 1. 1 minus 1 is 0. 6 minus 6 is 0. I'm all set. So now x of t is equal to c1 v1 e to the minus 2t plus c2 v2 e to the minus 5 e to the 5t. Okay, and now I have to check my work. So I'll rewrite that. X of t is c1, and v1 was minus 1, 6, minus 1, 6, e to the minus 2t plus c2, 1, 1, e to the 5t. That being the case, x1 is equal to minus c1 e to the minus 2t plus c2 e to the 5t. x2 is 6 c1 e to the minus 2t plus c2 e to the 5t. x1 prime equals 2 c1 e to the minus 2t plus 10 c2 e to the 5t, and x prime 2 is equal to minus 12 c1 e to the minus 2t plus 5 c2 e to the 5t. Did I do something wrong?
You have to get 5 out of 10
Oh, I don't know.
on that x1 prime.
It depends on whether my eraser can get small enough. Alright, fine. Alright. Now the book says that x1 prime was supposed to be 4x1 plus x2. Right? So that's minus 4 plus 6 gives me a 2 c1 e to the minus 2t. 4x1 gives me 4 plus another 1 gives me 5 plus 5 c2 e to the 5t. Check. And x prime 2 is supposed to give me 6x1 minus x2. Okay, 6x1 minus x2. Okay, so 6x1 is minus 6, x minus x2 is minus 6, so this is going to be minus 12 c1 e to the minus 2t, and it's supposed, then I'm supposed to have six of these guys minus 1 would give me plus 5, 5 c2 e to the 5t, and that's exactly what I have. Check. Okay, so problem number 2, or problem number 4 checks appropriately. Now we didn't do one with initial conditions, so number 6 has initial conditions, so we'll do number 6 next. You are supposed to do the odd ones, and I'm doing every odd one, so I'm doing more than I'm supposed to. So we'll do 6, and then we'll skip down to maybe 16. Okay, so I got x prime is 9x1, 5x2, x2 prime minus 6x1 minus 2x2, and I know that x1 at 0 is 1 and x2 at 0 is 0. Okay, so that means I'm going to be able to solve for C1 and C2 this time because I have initial conditions. Okay, I find that A is going to be 9, 5, minus 6, minus 2. I want to find the eigenvalues, A minus lambda I, and the determinant of that, and I want to set it equal to 0. Okay, so A, 9. So I'm going to have 9 minus lambda 5 minus 6 minus, put the minus 6 in a different spot, minus 6 minus 2 minus lambda, and I want that determinant equal to 0. Okay, so I got 9 minus lambda times minus 2 minus lambda minus a minus 30 is 0. Okay, so I got minus 18. I've got minus 7 lambda plus lambda squared plus 30 is equal to 0. Okay, that is what I've got. Okay, so I got lambda squared minus 7 lambda plus 12 is equal to 0. And as in all 9th grade algebra problems, that makes it extremely easy, right? I mean, how many different combinations can we have where we can solve in our head? So lambda is equal to 3 and 4. And again, we're in order. We don't go and put 4 and 3. All right, now we want to find the eigenvectors. So case 1, lambda 1 is equal to 3. I want A minus lambda I times V1, and I want to set it equal to 0. Okay, so A is 9, 5 minus 6 minus 1. 9 minus 3 is 6. 9 minus 5. 9 minus 3 is 6. Minus 6. Minus 6 minus 5. V1 has to be 0. Well, I'm going to pick minus 1, 1. What do you think? Looks good to me. Okay, case 2. Lambda 2 is equal to 4. Lambda 2 is equal to 4. All right, so I want A minus lambda 2I times V2, and I want to set it equal to 0. Okay, so I got 9 minus 4 is 5. I got a 5. I got a minus 6. And I've got a 2 minus 4 is minus 6. V2 is equal to 0. So V2 is equal to minus 1, 1. Which begs the issue, how did I get the wrong answer for the first one and not one of you complain about it? How is that even possible? So this is going to be 5, 6. Minus 5, 6. Is that better? You're going to tell me about that sometime, aren't you? I hope so. All right, so that being the case, x of t is c1 v1, which is minus 5, 6, e to the 3t plus c2 minus 1, 1, e to the 4t. Okay, and we have that x1 is equal to minus 5c1 e to the 3t minus c2 e to the 4t, and we have that x2 is equal to 6c1 e to the 3t plus C2 e to the 4t. Now we have initial conditions to apply. X1 at 0 is 1. So this implies that minus 5C1 minus C2 is equal to 1. And X2 at 0 is 0, which implies that C6, C1 plus C2 is 0. Okay, so I have two equations, two unknowns. And I find that C1 is equal to, okay, so on the bottom I'm going to have minus 5, 6, minus 1, 1. And on the top I'm going to have 1, 0. And I'm going to have minus 1, 1. So on the top I have a 1, and on the bottom I have a 5 minus a minus 6, which is a 1. So C1 is 1. If C1 is 1, then C2 had better be minus 6. C2 is minus 6. Okay, so now I'm going to write down my final answer. X of t is equal to V1. Anybody remember what V1 was? Minus 6, 5. Minus 6, minus 5, 6, e to the 3t minus 6 times my vector minus 1, 1, e to the 4t. And I'd probably bring that minus 6 inside. So I'd say x of t, new final answer, minus 5, 6, e to the 3t plus 6 minus 6 e to the 4t. And now we'd start correcting our work. So x1 is minus 5 e to the 3t plus 6 e to the 4t, and x at 0 is supposed to be 1. Check, it is. X2 is equal to 6 e to the 3t minus 6 e to the 4t, and x2 at 0 is supposed to be 0. Check, it is. X1 prime minus 15 e to the 3t plus 24 e to the 4t. X2 prime 18 e to the 3t minus 24 e to the 4t. Now, x1 prime is supposed to be 9x1. x1 prime is supposed to be 9x1 plus 5x2. Okay, 9, that's be 9 minus 45 plus 30 e to the 3x. What's that, 54? 54 minus 30 e to the 4x, 4t, t, changing variables there. Here I've got minus 15, there I got minus 15, over here I got 24, I got 24, check. And x2 prime is supposed to be minus 6, x2 minus 2, x1, 6x1, 2x, boom, 2. Okay, so, and this is going to be 30 minus 18 e to the 3t plus minus 36 plus 12 e to the 4t. And here I'm supposed to have 18 there. Why don't I have 18 there? 30, this is a 12, that's why. Okay, 30, 12, so I got 18 there, I got minus 24 there, check. So that checks as well. Oh. Well, the rest of these look pretty boring, so we should stop. Go down to 18, right? Where we have 3 by 3s. Now, maybe we shouldn't be trying to do these on the smartboard. There may not be enough room, okay, because I gotta think about a lot, right? All right. Well, I'll try to write small. All right, number 18. All right, so I got x prime equals 1, 2, 2, 2, 7, 1, 2, 1, 7, x. Okay, so that's my A. So I want to go A minus lambda I, determinant of it, and set it equal to 0. Okay, so I've got 1 minus lambda, 2, 2. 2, is that a 7? That's a 7. 7 minus lambda, 1. 2, 1, 7 minus lambda. Okay, do we know how to do a 3 by 3 determinant? 1 minus lambda, 7 minus lambda, 7 minus lambda, plus 2 times 1 times 2 is 4. 2 times 2 times 1 is 4. Minus 4 times 7 minus lambda, plus 1 times 1 minus lambda, plus 4 times 7 minus lambda has to be 0. Now, what are the chances of me actually being able to get this right? I don't know. So I've got 7 minus 8 lambda plus lambda squared, 7 minus lambda plus 8 minus 28 plus 4 lambda minus 1 plus lambda minus 28 plus 4 lambda has to be 0. Okay, so as long as I keep my wits about myself, I should be okay. So I got 49. Anybody know what 7 times 6 is? 7 times 8 is? 56? Yeah, okay. Minus 56 lambda plus 7 lambda squared minus lambda cubed plus 8 minus 28 plus 4 lambda minus 1 plus lambda minus 28 plus 4 lambda. Alright, so I got minus lambda cubed plus 7 lambda squared minus 9. Is that 47? 47 lambda. Okay, and over here I've got a calculator that's not turned on. Okay, so I got 49 plus 8 minus 28 minus 1 minus another 28. 0, 0. Oh, 0. That's good. I like 0. Do you like 0? I like 0. I don't like this 47 though. 56 minus 4 minus 1 minus 4. 47. 47 is a prime number, isn't it? It is? That sucks. Lambda times minus lambda squared plus 7 lambda minus 47 equals 0. These guys are supposed to be easy. I should be able to factor that. So that gives me pause. And at this point, we can't see enough of the board to know whether or not I messed up. 1, 2, 2, 2, 7, 1, 2, 1, 7.
How do you do your two determinants?
Okay. Now you ask. A, B, C, D, E, F, G, H, I. Okay, and I want to take the determinant off. So I recopy over A, B, D, E, G, H. Okay, and I say those guys multiplied together plus those guys multiplied together plus those guys multiplied together minus these guys multiplied together minus those guys minus those guys. Is that perfectly clear?
I was just wondering, I do it a different way, I didn't know.
But I don't write it down.
Oh, yeah.
Okay, so that's A, E, I plus B, F, G plus C, D, H minus G, E, C plus H, F, that looks like an H, H, F, A plus I, D, B. Okay, that's how I do it. Or I put it in my graphing calculator and have it do it.
Okay.
Either way. Okay, does that answer that question? The issue is, do I have to continue with this stupid problem or have I made a mistake yet? Boom, boom, boom. Okay, so that's right. 4, 2 times 2 is 4. 2 times 2 is 4. Minus 4 times that, 1 times this, 4 times that. Okay, so I did it right to there. I'm multiplying out 7 minus 8, boom, 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 8, minus 24 plus that, minus 1 plus that, minus that, plus that. I did that right. 7 times 7 is 49. 7 times, I didn't do that right, did I? Shit. Okay, 7 times 7 is 49 minus 7 lambda. Okay, minus 56 lambda, plus 8 lambda squared, plus 7 lambda squared, minus lambda cubed. Is that better? And that would explain why I have such a weird answer in a problem set that is so elementary simple, because it has to be, in order to solve it by this stupid method, it better be simple. See how that works? Minus lambda cubed plus 15 lambda squared. Okay, so I've got minus 56 minus 7 plus 9 minus 54 lambda, and this is still 0, right? Plus 0. That still doesn't factor. That still doesn't factor nice. Lambda times minus lambda plus 15 lambda plus 54. How's it going to factor?
Negative, pull out a negative 17. So like, I pulled out a negative
17 and
No, that's
was
and then got 9 and 6.
9 and 6?
Yeah, if you pull out a negative.
All right, so minus lambda minus 6 lambda minus 9. Okay, so make this guy a positive, put a negative there. Is that what you're telling me?
Yeah.
Okay, so I bring out a negative. This is now a negative. Okay, it factors. Okay, so I have lambda's eigenvalues at 0, at 6, and at 9. Okay, so now I'm happy. My problem went and gave me simple answers. Okay, so case 1. Case 1, lambda 1 is equal to 0. Okay, so I'm going to take A minus lambda 1. Okay, so what was the original matrix? 1, 2, 2. 2, 7, 1. And
217.
2, 1, 7 times V1 has to be 0. So by inspection, what is V1 going to be? Okay, I'm going to go with minus 4, 1, 1. Minus 4, 1, 1, minus 4, 1, 1, minus 4. Okay, good. So how easy that was? Did you get minus 4, 1, 1 before I got it, or what? Oh, you guys, you're just killing me. I'm 63 years old and I can see it. All three of you added together don't make it to 63. I guess it's not fair. I've worked these problems for the last 8 years. So. Anyway, now that you see minus 4, 1, 1, do you see that that's the right answer? Yeah. So
64, so yeah, we're
okay, so you're older than your combined age is older than me. All right.
That's why we couldn't get it.
Shit. All right. So now that I tell you it's minus 411, do you see that it's minus 411? Okay.
How would you do it otherwise?
I wouldn't. That's the only way I would do it. Because there's an infinite number of solutions, right? And no matter what else you do, you're going to be hosed. So, okay, I'm going to be hosed x plus 2y plus 2z is 0. And 2x plus 7y plus z is 0. And 2x plus y plus 7z is 0. And I'm going to solve those simultaneous equations, and what am I going to find out?
So if
There's no unique solution.
You can just put whatever x's and y's are in, right?
You could, yes. So you could say, okay, x is going to be 1. If x is 1, then what are y and z? Yeah. But you wouldn't do that. You do it by inspection. Otherwise, your whole city. Okay, case 2. Your whole city, anyway. Case 2. Lambda 2 is equal to 6. All right, so I'm going to have minus 5, 2, 2, 2, 2, 1, 2, 1, 2. V2 is equal to 0. All right. So is that fine? So by inspection, V2 is equal to what?
So, each time you do these, is only the middle column of the identity change then? Because of lambda?
Yeah, because lambda, because of I. Yeah, because of the identity thing only has something on the diagonal.
Okay.
So the only thing that's changing is the diagonal. All right. Oh. Now you guys got me all befuddled. I can't see it. Well, of course I can't see it, you idiot. Didn't do it right. Thank you very much. Big marker, big eraser. Okay, so 6 minus 1, 1 minus 6 is 5, minus 5. 2, 2, that's a 1, that's a 1, that's a 1, that's a 1. 0 minus 1, 1. Okay, so if I did the A minus lambda I right, it'd be easier to see that, right? All right, now I need case 3. Case 3, lambda 3 is equal to 9. All right, I'm going to have 3 more subtracted there. Minus 8, 2, 2, 2, minus 2, minus 2, 2, no, 1 minus 2. And this guy here is a 1. V3 is equal to 0. V3 is equal to, by inspection, what is it going to be? 1, 2, 2. 1, 2, 2. 1, 2, 2. 8 minus 8. 4 minus 4. 4 minus 4. All right, so I found V1, V2, V3 by inspection. And now I'm going to write that x of t is equal to C1 V1 e to the lambda 1t plus C2 V2 e to the lambda 2t plus C3 V3 e to the lambda 3t. And I'm going to rewrite that. X of t is equal to C1, and then V1 was minus 4, 1, 1. E to the 0t is 1, I don't have to write it down, plus C2, V2, 0 minus 1, 1. E to the 6t. Plus C3 V3 1, 2, 2 e to the 9t. Now again, this number, this eigenvector, did somebody say something who isn't sitting in the front row? And how idiotic was it that he said it? Don't anybody laugh at Andy, though. There's too many Andrews in the room. They'll take it poorly and turn red. No, I didn't leave out the e to the 0t. It is there. I can clearly see it. So what we're going to do, we're going to break from tradition, and we're going to look at the back of the book and see if that's anywhere near the right answer. So what problem was this anyway? 18?
Yeah.
And that's nowhere near the right answer. Wait a minute. No, it is the right answer. This is not a 6 up here. This is a 0 right here. So that's a 0. So 18, 1, yeah, 1, 1, 1, yep. Okay, got the right answer. Check with backup book. Now again, the backup book is not going to have an identical answer to mine, but it's going to be a multiple of those eigenvectors because he chose a different set of eigenvectors. So there's nothing wrong with choosing 4 minus 1 minus 1 or 0, 1 minus 1, right? You could have done that. That's perfectly okay. All right, so that one's done. That was 18. How far do we go in this thing anyway? We only go to 21. That means if I do 20, I can be done, right? Number 20. Now, when I did this at UNO the last time, my lovely instructor did one 2x2 guy and then walked away, expecting us to be able to work the rest of the problem by hand. All right, so A is equal to 513, 171, 315. 315. And A minus lambda I determinant of is equal to 0. So I got 5 minus lambda 1, 3, 1, 7 minus lambda. Wouldn't it be better if I had some zeros here? Come on, guys. Give me a problem with some zeros in it. 5 minus lambda. All right. I think my calculator will solve 3 equations. It will solve this equation for me. I'm pretty sure it will. Yeah, and I know your graphing calculators will. 5 minus lambda, 7 minus lambda, 5 minus lambda, plus 3, plus 3. Really? That's all. Minus, in parentheses, 9, 7 minus lambda, plus 5 minus lambda, plus 5 minus lambda, close parentheses. So I got 5 squared plus, that's 25 in case anybody's in 25, plus lambda squared times 7 minus lambda plus 6 minus 9 times 7 is 63, right? 63 minus 9 lambda plus 25 minus 2 lambda is supposed to be 0. 25 times 7, you got to be kidding me. 175? 175 minus 25 lambda plus 7 lambda squared minus lambda cubed plus 6 minus 63 plus 9 lambda plus 2 lambda plus 25 minus 25 minus 25. Okay, so I got minus lambda cubed plus 7 lambda squared minus 11, 14 lambda plus, okay, so I got 1, 7, 5 plus 6 minus 63 minus 25, 93, you gotta be kidding me. Has to be 0. All right, now I have a polynomial solver, a third level polynomial solver. Oh, yes, minus 1, 7, minus 14, 93, solve. Oh, I don't believe it. I don't believe it. Lambda 1 is 6.919192208. And lambda 2 is 0.0404038962. And lambda 3 is the same, 0.0404388962. And lambda, that's all there are? There's got to be 4 solutions. Where's my other solution? That's 2. There has to be 4 solutions, right? No, there's only 3 solutions. All right. So there's only 3 solutions. Those are they. Show of hands, how many think those are the correct solution? Shit, of course not. And which problem are we working anyway? 20? Number 20. My lambdas are 9, 6, and 2. Or number 20. Those are clearly not 9, 6, or 2. Well, that's okay. I got it wrong the last time, too. All right, so we'll take my red pen out. 5, 7, 5, 1, 3, 1, 1, 3, 1. All right, I have the problem right. Do I have the? Did I even use the right problem? 5. Okay, I got the right problem. That guy, that guy, that guy. Plus 3, plus another 3, minus 9 times him. One of those, one of those. So I got the problem written down correctly there. This is 25 plus lambda squared, minus 10 lambda. Okay, so there's a minus 10 lambda that goes in there. And there's a 6, that's right. 9 times 7, that's right. 9, that's right. What's 5 plus 5? Anybody know what 5 plus 5 is? You guys have to help me out here every now and then, you know. Especially if I don't get 5 plus 5 right. Alright, so this becomes a minus 10. And I have a minus 70 lambda. And I've got a plus 10 lambda squared. Okay. So that's right. This is now 17 lambda squared. Okay. Minus 25 plus 11 minus 70. So it's minus 84 lambda, 175 plus 6 minus 63 minus 10 is 108. Okay. I'm going to do it again. Second function polynomial solver, third degree polynomial. Okay, minus 1 is correct. 17 minus 84, 108. Solve. Oh, look at this. I don't believe it. X is not this piece of crap thing here. Lambda 1 is 9. And lambda 2 is 6. Lambda 2 is 6. And lambda 3 is 2. Exactly what the back of the book predicted. Isn't that lovely? Good thing I have another. Okay, if I was doing it without the calculator, I would say, first of all, it'd have to be one of those types, right? Yeah, so, and I'd say, well, because this is a 108 and I expect an even number, I'm going to look at plus or minus 1. I'm going to look at plus or minus 2. Because that's odd, and then 108 is divisible by 3. Then I'd look at plus or minus 3. So I look at all the factors of 108. So I put a 1 in. Nope, it doesn't work. Put a minus 1 in. Even worse. Put a 2 in. 2 works. All right. So now I know that 2 works. That means that I can divide this by lambda minus 2. So I go lambda minus 2 into the third degree polynomial would give me a second degree polynomial, which I can now factor. So that's, but you learned that in pre-calculus. You did that in 9th grade algebra. That's how you do it in 9th grade algebra, right? But so that's how I would do it. I would look at this. I'd divide by whatever this guy is first. Okay, there's a number there, and then I'd look at this guy and do factors of him. And I can check 1 and minus 1. I can figure that they're wrong. And then I have to put 2 and minus 2 in my calculator. I wouldn't even put minus 2 in because I know that's wrong. So I'd put 2 in and I find that it's correct. Is 2 correct? Minus?
So you put 2 in and then you get 9 and 6 after?
Yeah, so if I put a 2 in, I got minus 8 plus 17 times 4 minus 84 times 2 plus 108 equals 0. So I know plus 2 is a factor. So now with plus 2 as a factor, I do that long division again, and then I solve for the other 2 guys. All right, back.
How come it's lambda minus 2? Is that because you said it equal to 0?
I don't understand the question.
Lambda minus 2 in front of the
Division's not either.
Well, if it's plus 2, if the root's plus 2, then the factor is y minus lambda minus 2. Yeah, so if the root is plus 2, then it'd be the variable minus 2 would be the factor. Yeah, okay, good enough? Okay, case 1. Lambda 1 equals 9. Okay, so I've got minus 4, 1, 3. I've got 1, minus 2, 1. I've got 3, 1, minus 4 times V1 has to be 0. So by inspection, V1 has to be 1, 1, 1. You were going to tell me that, right? Yeah, it was on the lips. Okay. All right, it's case 2. 2 lambda 2 is equal to 6. And lambda 2 is equal to 6. I'm going to go minus 1, 1, 3. I'm going to go 1, 1, 1. And then I'm going to go 3, 1, minus 1. V2 is equal to 0. And I'm going to write that V2 is equal to, by inspection, by inspection. All zeros is a non-answer.
It works though.
Well, all zeros always work. It's the trivial answer. Oh, all zeros. You guys, anyway. 6. 6. Okay, so minus 1, minus 1. It's a 7 there, 1. Okay, so I didn't write it down wrong.
Can you do 1, -2, 1?
Oh, I was just about to write that down, as a matter of fact. So 1 minus 2, 1 works, yes. Well, I had that a good 5 minutes ago, naturally. I just didn't want to jump the gun and, brag or anything, pretend like I was smart. Case 3, lambda 3 is equal to 2. Okay, so lambda 3 is equal to 2. And okay, lambda 3 is equal to 2. So I got 3, 1, 3, 1, 1, 1, 3, 1, 3. Times B3 is equal to 0. You better tell me what this is before I write it down, or I'll be very disappointed. Oh, guys, I don't believe it. I wrote it down before you could tell me?
Shouldn't the middle number be a 5?
Oh, I don't know.
7 minus 2 is 5.
Let me check. 7 minus 2 is 5. Does that change my answer? No. Still the same answer. All right, so x of t. C1 V1 1, 1, 1. 1, 1, 1. E to the 9t plus C2 1 minus 2, 1 e to the 16 plus C3 minus 1, 0, 1 e to the 2t. And I would imagine that checks with the back of the book, and that would be okay too. All right, well, next time, I don't believe we're going to do 5, 5. Don't we do the section where we have multiplicity of eigenvalues? There it is, 5, 6, multiplicity of eigenvalues. Oh, it'll be so wonderful. No, you have one set of rules down, you have to learn another set. Okay, so I guess that's all we're doing today.